Welcome to this session on how to supercharge application security with Spring Security, OpenID Connect, and OAuth2. My name is Mark Heckler, and I'm a Spring developer and advocate with formerly Pivotal, now VMware, still on the Spring team. And if you have a question, comment, or feedback afterward, I can be reached via email at either of the two email addresses shown, or better yet, on Twitter. I constantly am on Twitter. I live on Twitter, so that's the best way to reach me. If you have questions, comments, or feedback that you don't want to share with the world, my DMs are open as well. So please feel free to reach out. So, a bit about myself. I have co-authored a couple of books. I've contributed content and code to several other books. I actually have another book in the pipeline, which I'll introduce here momentarily. But most importantly, I am an architect and developer by trade, and as you might surmise from the next bullet point where most of my expertise has been won, it's been in the JVM ecosystem. I am a Java champion, Java 1 rockstar, groundbreaker ambassador, have received a few other honors and awards that, while I do truly appreciate them, still mean I have to buy my own coffee. I don't know who I need to see about that, thus I'm still buying my own coffee, but it is what it is, right? Hopefully you have some coffee as well while we're going through this. So I am a professional problem solver, as are you, or you wouldn't be here, so I appreciate you coming. I am a Spring developer and advocate, as I mentioned. I work a lot with Spring Boot, some with Spring Security, some with Spring Cloud Stream, and et cetera, and so on. So I get to play with all the toys. I get to do my two favorite things in the world for a living, which are develop code and talk to people. So again, thanks for coming. I am also the sole creator and curator of Spring Noticias en Español. So if you are a Spanish speaker, if you have resources that you want to share with the greater Spanish-speaking Spring community, please let me know and let me help amplify your voice and help the entire community as a whole. So one wins, we all win. Again, the best way to reach me is at the Twitter handle below, mkheck, or you can hunt me down via email at thehecklers.com, mark@thehecklers.com as well. So I mentioned a new book that will be coming out in August. Now, this is not the real title, but I actually am under a contract with O'Reilly. I'm working on it now. And O'Reilly apparently puts a lot of time and effort into choosing the proper animal for the cover of books. Me being a bit of an impatient sort, I thought, well, how hard can it be, right? I wanted, the title is correct, Spring Boot Up and Running. So I thought, well, something running. I kind of consider myself a higher primate. So I thought, why not, right? Running monkey. And this is the best I could find. Hopefully they won't stick me with this cover. This remains to be seen, but coming this August. So if you're interested in kind of a gentle introduction to Spring Boot, as well as diving deeper into topics, kind of hitting that intermediate stage of topics that kind of naturally flow into how to develop Spring Boot applications that are production deployable, please do check it out. Please follow me on Twitter for future announcements. So with that, let's jump right into what we're hoping to cover today. And generally I get about 3 hours for this. Okay, maybe that's a slight exaggeration, but we have 50 minutes today. So I'm going to hit this rather quickly so we can get started. We're going to cover the foundational security concepts using Spring Security, and that is a 100% open source software. Everything I show you today pretty much is well, it is open source. So we're going to talk about Spring Security, Spring Boot, and we're going to authenticate, and we're going to cover all the good stuff, and it's 100% open source. Check out Spring Security. You can download the bits. You can download the code. You can contribute to the code. We're very community driven, so please do feel free to jump in and participate. And yeah, it's just a great community, a solid community to come together and help secure our applications, do better with that. We'll talk about authentication and authorization, or as I like to say, who's who in the zoo. Although, to be honest with you, that phrase is actually just half the story, who's who in the zoo. And I'll get into that momentarily as well and explain myself in that regard. We'll talk about OpenID Connect and OAuth2, what they bring to the table, what the value is that they offer. We'll talk about roles involved. We'll talk about the grants involved. No, not those grants. No, but the grants involved in what we're going to be discussing in terms of authorization grants. And then we'll code, right? Because if you're anything like me, you kind of understand things better when you see them put into action. So yeah, that's the best way to do it, right? So let's start here with a kind of a 3,000 meter view of Spring Security. And there's a lot to Spring Security, as you might imagine. There are a lot of threats to try to counter, right? So it has to be a fairly complex undertaking. However, I think we can distill this to three main principles, main topics, and it covers most of the ground really well. So let's start there. Since Spring Security 5, which is over a year now that's been generally available, we have included an HTTP firewall. Now that's very important because many attack vectors are exposed in various different systems and applications because of a malformed URI. That's typically the first avenue of exploit, if you will, for trying to compromise a system. So if you can feed a bad URI to an application that will accommodate that and try to decipher what may have been intended and fix and adjust and massage, and then process that URI, even though it's bad, or worse yet, just absorb it as it comes in, that opens up a lot of attack surface to malicious actors. So the HTTP firewall is kind of that first line of defense. It examines URIs for any bad characters, any bad patterns, and if it finds any of those, it just discards the request entirely. So if it's not a valid URI that comes in, the request goes nowhere, which closes a huge gap in a lot of security profiles. Next up is the security filter chain, which is what I consider to be kind of the secret sauce of Spring Security. I'll get into this a bit more momentarily, but at a very high level, basically what it consists of is a chain of filters through which all requests must pass before they're processed. And as soon as a request matches a filter in one of many different criteria, that request is processed. And if it doesn't, if it falls all the way through all of the filters and doesn't hit a matching filter, it's just discarded, which closes another avenue of attack against your applications. Next up, we have request headers, and I'll get into this in more detail as we go along as well. But the request headers are specifications by the W3C, the World Wide Web Consortium. And these headers are put into place so that your applications can expect and process and use these headers to make your applications more secure. Again, we'll get into that more momentarily. And of course, there's much more. Things like password hygiene, always using TLS, transport layer security. By the way, just as a quick aside on that, Google converted all of their communication, internal and external, to HTTPS or TLS. And you remember that when TLS and before that SSL was being advocated for inclusion and use in various different interactions between microservices and different systems, there was a performance penalty. And when Google converted all of their communication to TLS a few years ago, what they actually found in hard numbers was that there was a 1% CPU performance hit, 1%. And the network performance hit was 2%. So it's effectively no additional burden, and it makes your communication secure. So there is just absolutely no excuse anymore to not use TLS everywhere. And other things too, other topics like storing your secrets securely and data at rest should be encrypted and so much more. But again, we have to scope down so we can get through what we have, what I really want to cover today. And again, if you want to cover more of this later, talk about it at some point, by all means, please contact me. If I do, and I do want to say that if I do happen to not give something sufficient weight or coverage that you feel like you wish I'd covered more, chances are I feel the same way just because of our time constraints. So please do reach out to me, and happy to pick up the conversation and carry it on at length later on. So getting back to the security filter chains, as I mentioned in Spring Security, we can actually accommodate numerous security filter chains. However, in practice, what we see typically is that there is a security filter chain with a handful or a number of filters that process each request that goes through this filter chain to see where it connects, where it matches up and is processed. So again, you have a lot of different options there. You can string together numerous filter chains, but in most cases, a number of filters are processed. A request comes through. As soon as it hits a match, it comes out. It's processed and handled correctly. Now, it is important to note that the most specific filter should be first in line. And that's very important because if you have a number of filters, what typically happens is check this pattern. If it matches this, process it this way. If it matches this pattern, these permissions are expected or required. And if it matches this pattern, do this. And if it doesn't match any of those, all requests are honored. All processing is allowed, right? So the problem with that, of course, is that if you put that and all requests are handled, all access is given up front, then everyone has access to everything. Now, why would that be in there at any rate? Well, because if I hit a landing page or a login page and I haven't logged in, I'm accessing this from a new browser, from a new location, whatever, I want to be able to log in. I need to be able to log in so that, and all other requests are allowed, that should be in there in the filter chain. It should just be at the end. The most specific has to come first. The least specific needs to come at the end. Very important to make sure that order is processed that way. Okay, now back to the headers. These are very important, right? Because the W3C, as I mentioned, has established certain headers that can be put into place and that help your application know what to do and how to process requests, secure your application. So things like cache control. And by the way, I do want to point out that Spring Security is secure by default. In every way that it can be, it takes the most secure position out of the box. And if you need to back that off, you can do that. But the hazard, if you approach things from a least secure and then you can tighten down where you want to, is that we know, just as any developer using any tool chain, we know that there will be a small percentage, whatever it is, 3%, 13%, 22%, but there will be a percentage of applications that will proceed all the way to production with the default settings. So you never want a security library to establish a very lax position up front, assuming that someone will come back and tighten things up. That in a certain number of cases, out of the total number of cases, that just won't happen. So we take a secure by default posture, because that way you can be assured out of the box that based upon what information you've provided or what maybe you haven't provided at this point, then your application is secure as it possibly can be, pending any adjustments you need to make. Things like, for instance, cache control. So cache control, we've established values of no cache, no store, max age 0, must revalidate, pragma of no cache. And that's important because, as an example, if I were in my office and I'm on my banking site and I'm checking my balances, and then I think, well, great, I have enough money in there that I can bid on that thing on eBay that I really want to get. So then I go from my banking site directly to eBay, and I pull up eBay and I look at it and I say, hey, come here, Alice, take a look at this. I'm bidding on this thing and I think I might win this. And then I walk away for a second, or I take a call, and Alice looks over my shoulder and clicks the back button in my browser. What happens? Well, if caching is in place, then she may have access to all my banking information. That's typically not the outcome you want. So we need to disable caching. We need to stop that kind of thing from happening so that you have to revalidate when you come back to a page that you've moved off of. We also have things like set cookie to HTTP only, so that the cookies are only processed by server-side logic and not by client logic like JavaScript in your browser. Things like X content type options set to no sniff, because a user agent, a browser in many cases, may try to process a PNG or a JPEG or a PostScript file and say, I know what that is. I can just display it. I can take that initiative and do that myself. The problem is that any of those files and numerous other files can contain malicious code. And if that is just processed by an overeager browser, then that can result in bad things happening on your machine, on your client. So we want to disable the sniffing of content. We want to, of course, when that happens, we have to, if we're going to process PNG files or PostScript files or what have you, we need to actively handle that ourselves. We need to code for that, but it closes, again, an entire attack vector. We have X-frame options set to deny, and that's important because of clickjacking. Clickjacking is where you may think you're clicking on one visual element on your screen, and you're actually clicking on an invisible frame sitting on top of that. So if someone has located an invisible frame over your submit button, and you think you're submitting your email address to a mailing list, what you may actually be doing is something completely different. And at that point, of course, once they execute a script, they can go ahead and click on the button and you're none the wiser. We want to disable clickjacking or hijacking of your clicks. And the way to do that is to set X-frame options to deny. We also want to have cross-site scripting protection. That's set to 1. It's set to block that. And if you're using something like a content delivery network, you may have to back that setting off a bit. But again, most secure by default out of the box, which is very, very comforting and establishes that kind of that harder baseline to crack into your application, which is on balance a very good thing. Next up, we have authentication versus authorization. And I mentioned the who's who in the zoo part. That's actually half the story. Who are you? And that is what we refer to generally as authentication. So whether it's your driver's license or your passport or your frequent shopper card at your grocery store, you have to have something to authenticate in whatever context that you're authenticating. Can you prove you are who you say you are? And that very simply put, is authentication, just confirming, yes, I am who I say I am. And then we get into authorization. What can you legitimately access? So if I go into a buying club like Costco, I have to show that I am who I say I am, but then they check perhaps the expiration date to see if I'm still authorized to come into the store. And at that point, I am both authenticated and authorized. I have established who I am. I have established that I have permission or authorization to access the resources that I should have access to. How that relates to our conversation is that authentication is performed by OpenID Connect, and authorization is actually handled by OAuth2. Now, such wasn't always the case. In the early days, there was a lack of both mechanisms, and then one mechanism, actually OAuth, came into being first, a version of OAuth, and then things kind of progressed from there. It took a little while to get to where we are now, but we're here. So our friends at Okta are a security company, and we'll be using some of their software, some of their libraries here shortly to complete some of the things that I want to show you via code. And our friends at Okta use an example of Yelp. I love Yelp. I'm one of the early users of Yelp. If you haven't heard of Yelp, it is an application that is useful when you go to a new part of your town or another town, a city, and you want to look up where you could get something to eat or get coffee or what have you. And Yelp was one of the early pioneers in that space. There are others now, but I still go back to Yelp. Yelp is, again, one of the pioneers and has a really great data store built up for great recommendations. Yelp also was a social application. They were one of the first to see that, hey, it's great to find restaurants, or in my case, coffee shops. I kind of live on coffee. But it's also very useful to know that if someone you trust has been to a place, what their thoughts on that particular shop were. So Yelp realized pretty early that they needed to be social. They needed to have an ability to make connections among groups of people. So, for instance, when I signed into Yelp way back, let's say, and I don't remember this, so I must not have been one of the very first supporters, but it certainly was an early adopter. But when you would sign into Yelp, Yelp would prompt you for your user ID, for your email address in this case. And you'd supply your email address, and they would say, hey, mark.heckler@gmail.com. That's great. Well, you're a Gmail user. Well, would you like to share your recommendations with your friends? Would you like to see their recommendations? And of course, the answer is, sure, of course. I would love to do that. So then they would ask, well, okay, give me your password. And that sounds terrible, only because it is absolutely terrible. But at that point in time, there was no easy way to do this. And Yelp was certainly not the only one, the only company, the only application who was doing this kind of thing. I use them as an example, not because they were a particularly bad example, but because they represent the mechanisms available at the time. So the problems with that kind of thing, when you would provide your email address and password, well, there were many, right? So to start off with, they had to store your credentials, your user ID and password, and typically they stored that stuff in clear text. That's a problem. The servers that they would authenticate to, so if I had a Gmail account, they would authenticate with Google, they would have to support password authentication despite the weaknesses inherent. And even if Google, even at that time, if they had a better way of authenticating via multi-factor authentication or what have you, they couldn't lock that down to only that because Yelp and several other companies had to be able to use the user ID and password to continue. Those third-party applications like Yelp would gain overly broad access to the resource owner's protected resources. So if I gave them my Gmail address and password, they would have access not just to my contacts, but all of my emails, my photos, my files, and that's rather significant. And then, of course, there was no way also to restrict duration, that they only have access for 5 minutes to gather my contacts or access to a particular subset of resources like my contacts. So that was problematic, to say the least. Resource owners couldn't revoke access to an individual third party without revoking access to all third parties. And they had to do that via a password change, which meant everything broke at once. So you had a lot of cleanup to do if you had to do that. And of course, if any one of those third parties was compromised, that meant that all of your data, all of it, everywhere that it had access to via that user ID and password was compromised as well. So you can see as how this would be a bit problematic. OAuth was created, the original OAuth 1.0 was created to address these issues and really didn't do a phenomenal job of it. Followed quickly by OAuth 1.1, also made minor headway, but still didn't get very far and had some problems with it as well. OAuth 2 came on board. OAuth 2 was actually widely adopted, kind of closed all the loopholes that 1 and 1.1 had and was enthusiastically received. The problem with OAuth2 is that it covered the authorization part of the puzzle and not the authentication. So you had big providers like Google and Facebook and GitHub and things like that that would provide that as their own extensions to OAuth2. They would provide the authentication portion themselves, which meant that you had a lot of semi or incompatible options for authentication, even though the authorization part was standardized. OpenID Connect is actually a kind of a shim that sits on top of OAuth2 and is standardized. So we're back to a good place now, or to a good place now. So we're going to talk about the authorization code grant here a bit. There are major roles involved. So things like a resource owner, that would be you, that would be me, people who own a particular resource that we want to get to. We have a client which operates on our behalf. Maybe it's an iPhone, maybe it's a service that we're using to access a particular resource. We have an authorization server that will authenticate us and provide the information about what authorizations we may have to the requested resource. And then we have a resource server, which should, in theory at least, provide us access to that resource that we want to get, that photo, that file, what have you. So we also, within the OAuth2 specification, the Internet Engineering Task Force, the IETF spec, we have different grants. So things like the resource owner password, which is kind of the old school user ID and password, right? That's not used as much anymore, as you might imagine, but it still does serve its purpose in very limited use cases. We have the client credentials grant, which is used for cron jobs and service to service communication and authorization. You also have the implicit grant, which was originally created for browsers and user agents where you weren't 100% sure they could be secure. It was kind of a compromise. We have the authorization code grant where you were fairly confident that you would be secure, which separated the browser, the user agent authentication with the actual client that would request access to the resources. And then extending that is the authorization code grant with PKCE, PKCE, which represents proof key for code exchange. This allows browser-based applications to embrace some of the security built into the authorization code grant with the PKCE extension. So it gives us ever more secure applications. There are, again, numerous options for how to get there, but everything is kind of coalescing, at least from that initial access point, around the authorization code grant in one of many ways, which is why we're focusing on that today. And of course, there are numerous steps involved, as you can see, but they're pretty simple when you walk through them. You have a client you're using to access a particular resource. So you provide a bit of information to your client and say, look, I want to use this app and I want to get to this resource on this resource server. The client says, oh, I have a client ID. I'm going to use the specified authorization server to see if you're allowed to do that. So it contacts the authorization server, typically via a browser, a user agent. The authorization server will prompt you for your authentication information. So the client will provide the client ID, as I started to mention. Sorry, I kind of diverted a bit. It'll provide the client ID in secret, the redirect URI. It will provide a response type expected of code. So it's a code grant. The user will authenticate directly with the authorization server via the user agent, the browser typically. And then once the authorization server says, oh, yes, you're authenticated, the happy path, it will return to the callback URL with an authorization code. The client then, not the user agent, so it doesn't hit your browser, it's not exposed, but it takes that authorization code and interacts with the authorization server directly, the back channel, if you will. And it exchanges that authorization code for an ID token, again, that authentication, and the access token, the authorization, which the client then provides to the resource server with the resource request, and hopefully the resource server will validate that access token, confirm that you have access to the resource you're requesting, and provide that resource. So again, it seems a bit complex. Really, when you break it all down, it's not that much. So let's write some code. That's where the rubber meets the road. I'm going to switch now to the Spring Initializer. This is where we start when we create Spring Boot-based microservices, and thus the URL, the start.spring.io address. Now, the Spring Initializer is not a requirement. You can actually create Spring Boot-based microservices by hand. You can create them as if you're crafting something entirely out of scratch. Not the best use of your time, so I typically kind of discourage that, but you certainly can do it. You can also access the URL via curl via HTTP. You can use your IDE to access the Spring Initializer, and you can get started in a variety of ways. I just like to come here because I think it's a really nice looking site, and it kind of steps you through very nicely on what you want to do. And it has a couple of other options too, like to be able to explore your dependency file, your build file, before you create the project. It has the ability to switch from light mode to dark mode. So depending on how you have your environment configured for dark or light, that's great. It doesn't jar you when you switch among the different tabs in your browser, if you will. So that's kind of nice. I have mine in dark mode, so it's comforting. If I have all my lights out, it doesn't immediately blind me for a while. So let's get started. I'm going to create just a couple of projects that we're going to use to build our application here and see how these would interact in a very secure way. So with the Spring Initializer, we can create a Maven project or a Gradle project, so whatever you prefer, by all means. And we can use Java, Kotlin, or Groovy. I'm going to stick with Maven and Java, just kind of stay down that middle of the road for today, but do what makes you happy. I'm also going to use the current version of Spring Boot 2.2.6, and that's fine. That's the production version. You can actually go with newer milestones and snapshots, or one snapshot back, one production version back, the latest revision. But again, there's really no reason not to use the production version. And I'm going to create the hecklers.com group because why not, right? And let's create a project called SSEC for Spring Security and OIDC app. So this is my OpenID Connect app. I'm going to use this app both as a client as well as what I'm going to use to authenticate and authorize for future access to different resources underneath, or at least ostensibly so. So I'm going to create a jar for the packaging, and I'm going to take it up to Java 14. You'll notice that we support the baseline of Java 8. It's fine if you're still on Java 8. We also support the other long-term supported release, or the long-term supported release, Java 11, and then the current version of Java, which is 14 as of just not that long ago, right? So we'll start there. I'm also going to choose some dependencies. Now I want to bring in a few dependencies here. So I'm going to bring in the Spring Web dependency, and that lets me create a web app. I'm also going to bring in the Spring Reactive Web dependency, primarily so I can get to the web client, the reactive web client. And that's a bit of a misnomer because it's not just for interacting with reactive systems, but it does let me access applications that expose reactive publisher endpoints as well as imperative object or iterable type of endpoints that you might run into in an imperative system, if you will. So I'm going to bring that in as well. I'm also going to include Spring Security, as you might imagine. And then because, again, Okta is a great security option for OAuth2 and OpenID Connect, I'm going to include that as well. And then I'm going to generate the project. And we'll just save that there on the desktop. I'm also going to change this and create, just in the interest of time, I'll create our resource server project. I don't need to include the reactive web dependency because it will be our resource server. I'm not going to use it as a client. Okay, I'm going to go ahead and create my resource server. And there we go. So I'm going to open my OpenID Connect app, and then we will go there. And we'll open that in our favorite IDE. Use what makes you happy. Let's go to our build file, and I'm just going to add a couple of dependencies here. So I'm going to bring in some dependencies that aren't by default wired into the Spring Initializer. So we have Spring Security Config, which allows us to do Java config for Spring Security in our applications. We also have the OAuth2 client dependency, which allows us to create an application that acts as an OAuth2 client very quickly and easily. And OAuth2 Jose. Now, Jose is the JavaScript object signing and encryption dependency, which brings in the capabilities to evaluate, to code and decode our JWTs, our JSON web tokens, so that we can pass those around, manipulate them, evaluate them, and that's all covered within this dependency. So let's go next to our application code, and we'll write some code. And we're going to want to come back to our application properties momentarily as well. But I do want to do something before we get there. Now, the quickest way to demonstrate this is just to create a simple REST controller. I'm going to map this just to / so we can start off just at the at the base URL. And then I'm going to create an application controller class, and we'll create a get mapping. Yeah, we'll just leave it plain, and we'll return a string. We'll call this hello method. So return hello there. Glad to see you. All right, we need more excitement. There we go. That's better. All right, so let's go ahead and run this, and we'll see what we get. The application starts up pretty quickly. And if we go to a browser, I'll just open a browser window here. Now this doesn't look like what you might expect if you're expecting an OpenID Connect OAuth2 application. And that's because this really kind of isn't at this point, because we didn't provide any kind of registered client information that we can use to authenticate, right? But what we do see is that Spring Security has us covered, because even though we didn't give it enough information to know even what OAuth provider to contact to handle this, it says, look, you have Spring Security on your class path. You don't have enough information to actually go to an authorization server, but you need security. You want security. So it provides some default security. So if we plug in user here and that password, we see that it actually has secured our application. It says, hello there, glad to see you. So we know that it's working, because what it's doing is it's using a security password for the application. Certainly not ideal, certainly nothing you want to leave in place, but it is securing that application the best it can with what non-existent information that was given, right? All it knows is you want it secured, it does its best. So how do we actually turn on the OpenID Connect and OAuth2 portions? How do we make our application? How do we enable it to use an authorization server to perform these functions? And I'm going to go over here. And I'm going to go to our application properties, and we're going to see how to do that. Now, what we can do is leave these properties so they're key value pairs, or we can rename this to YAML. Now, I don't have a strong visceral reaction to YAML if it's short and succinct and it serves its purpose. And I think this does here. So I'm going to add some properties here. I had those buffered so I wouldn't have to type those all out by hand. But as you can see, there's some repetition here. There's some nesting here. So in this case, YAML kind of makes sense. It's also short and succinct. So again, kind of makes sense here. And we're providing a couple of client registrations here, one with Google to authenticate and one with Okta. We're also indicating that the Okta configuration URI is here, so therefore our application can go and query that and get the other information it might need to go ahead and configure our app to use Okta around this configuration URI, which by the way is a standard as well. So with that, we can restart our application. Spring Security will have the information it needs to contact the authorization servers in the right places, provide them with the client ID and secret. And by the way, in production, please don't share your client secret. This is just, in this case I am, because it just reroutes back to my local host 8080 for an application. There's certainly no problem with that here. But again, in production, you typically wouldn't expose your secrets. You'd have them encrypted in something like HashiCorp Vault using Spring Vault. You'd have them passed in via environment or what have you. So as you can see though, we no longer have that default generated password because we now have clients we can use. So let's open our application again. Now, here we see that we have access to both Okta and Google in terms of mechanisms we can use, authorization servers we can use to authenticate and get the authorization we want that we need to access our resources. I'm going to start with Google. And as you can see, it's prompting me to log in. So I provide my email or phone number, in this case it's my email, and my password. And here is something that I think is a nice little extra at no extra charge, because since I'm using Google to authenticate, and I've told Google that anytime I authenticate with Google, I should have multi-factor authentication enabled. So it's requiring me to use, in this case, a security key. So I have a YubiKey that I use to log in, and that provides an additional authentication factor to prove, yes, I am truly who I say I am. Again, that's just part of the package, right? So I have Google set up to authenticate me, and it does that, and it requires that additional factor. So that's nice. I'm going to go ahead and log out now. And then we'll do the same thing with Okta. Now, Okta does have this capability as well, MFA, multi-factor authentication. I don't have it enabled because I like to show different different pathways in, if you will. But here I'm going into Okta and it does the same thing. So I'm being authenticated, it's passing me back, and life is good. Now, what we don't see at this point is any means to determine authorization, because if I'm in, I'm in. Which brings us to step 2. So I'm going to go back to our resource server and open that up, and we're going to create our resource server project. So first off, we're going to go to our POM, and I'm going to go ahead and add just a couple more dependencies here too. Our resource server dependencies. Once again, we have our Java config dependency. We have a dependency for our OAuth2 resource server. Instead of this being an OAuth2 client, as our other application was, this is an OAuth2 resource server, so it provides access to the resources we want to utilize to access. And then, of course, once again, OAuth2 Jose, so that we can decode our JSON web token and determine if we actually do have the permissions we should have to access the resources we want to expose. Next up, we'll go to our application properties. Once again, what I'm going to do, just for convenience, is change this to a YAML file. And then I'm going to add a few properties, right? So here we have our resource servers issuer URI once again, which is that self-service configuration URI that starts us off. Our application will reference that and then get the information it needs to get the keys and to be able to decode the JOTs. And then, of course, our server port we're setting up to 8081 so that we don't have a port conflict, which is never a good thing. And then let's write some code here. So right off the bat, again, I'm going to create a REST controller and a request mapping. This is our resource server. So I'm going to nest everything under resources to start off with. And this will be our resource controller class. I'm going to just create a get mapping here for /something just to kind of kick things off. Get something, return, this is really something. Why not, right? Naming is hard, examples are hard. But now in a real resource server, we would have resources, actual resources that we're gatekeeping, that we're controlling access to. So again, something like a photo or a file. In this case, I don't have anything like that built at this point. So what I'm going to do is we're going to examine our permissions coming in via JOT. We're going to examine that bearer token. So I'm going to take a look at our claims here. And a claim or claims are just a map of string object. There we go. And we'll say get claims so that we can check out what our claims are. I'm going to use our authentication principle here, which is a JOT once again, so we can evaluate that and see what we have. Return jot.getClaims, and that's pretty good to kick things off. But I do want to take a look at the email that's associated with it. Now, your email, your subject, if you will, in OAuth parlance, is a part of your claims, but it's kind of nice to be able to extricate that. So we'll get subject, and that's just out of convenience. We'll be able to have a convenience method here to get direct access to our subject. Return jot.getSubject. Very nice. Now, this shows what each endpoint should be able to do, right? But we have no way yet of controlling access to each of these endpoints. So I'm going to enable web security. We're going to create a class here. We'll call this security config, our security config class, and we're going to extend our web security configure adapter. Now, a web security configure adapter bean is already created on your behalf, but if you want to do anything specific like we're about to do, you need to override that, right? So I'm going to next override a configure method so we can do what we need here, and we will just create a few rules here, if you will, a few filters. So I'm going to authorize requests, and then we'll do an MVC matcher, and the matcher will be for resources, claims, **, and of course that matches claims, but it also matches anything that we decide to nest under that. And we will make sure that we have the authority. Everything is a scope in OAuth, so OpenID. So we will just check to see if we have that authority to access the claims or any sub URIs under claims. And then we'll also create another matcher here for another pattern for resources, sources, email. And then we'll verify that we have the authority for scope email. And then we want to do an and OAuth2 resource server jot so we can process our jots. And that should be sufficient for our resource server, just to, again, verify that we're able to get there, that we're able to access what we want to access and see what we want to see in the way we want to see it. So we do need to go back here, and to be able to access that as a client from our initial application, we're going to have to add a bit of code. So I'm going to create a web client bean, and we'll create a method to provide that for us here. The first thing I need to do is create a servlet OAuth2 authorized client exchange filter function, which sounds terrible, right? We can see right here that it is an exchange filter function, which just means it's part of that filter chain, right? And it's used to filter out based on your OAuth2 authorized client for servlet. And that just means an imperative, a non-reactive application. If you were building a reactive application, it would be the same basic thing, but you would have a server OAuth2 authorized client exchange filter function. So not today, that's another topic for another day, but it basically works the same. And we're going to create our filter function equals new servlet OAuth2 authorized client exchange filter function. Just rolls off the tongue. So it actually takes a couple of parameters, a client registration repository and an OAuth2 authorized client repository. The good news is these are beans that are already created for you. So we're going to inject those, the client registration repository, we'll call it the CLI repo for short, and our OAuth2 authorized client repository, which we will call our CLI repository. Sure, CLI repo, and this will be our reg repo, sure. Now, this looks very interesting, right? But our client registration repository, we've actually registered 2 clients right here, client registration. So these 2 entries will be in our client registration repository. Our authorized client repository includes, once we've authenticated, our authorized client, in this case, our application here. And then we just pass those, our reg repo and our CLI repo. There we go. Okay, so now I need to set the default OAuth2 authorized client to true for my filter function. And this is important because this just says that if you're already the default authorized client, if you've authenticated as you, then we should use your permissions for access to any subsequent resources. You don't have to do that. There will be certain cases where you won't want to do that. In many cases, that's not the case. If I want to access my Google Photo, it's me doing that, right? So this is why we set this to true and we charge on. And then we will return web client.builder, and I'm going to have the base URL set to http://localhost 8081 resources for our resource server, resources, and then I will apply our filter function, the OAuth2 configuration, which is a consumer, right? We're going to consume that, and then I'm going to build that. So now we have a web client bean we can inject here. So private final web client. I'm going to use constructor injection to go ahead and access that in our app controller. And let's test that we have everything wired up. So I'm going to get something, and I'm going to get that from our resource server. So we'll return a string, get something from resource server, and return. We'll use our client. We'll do a get. We'll add to the URI because we need to add something to the base URI, right? We'll retrieve that. We'll take that body, convert it to a mono of type string. A mono is just a reactive publisher type, 0 or 1. And it's very easy to go from a reactive type to an imperative type. You just block. It's not so easy to go the other way around. So that's the direction here that we're taking. We're going to check our claims, and that'll return a map. Yes, that's fine. Get claims. And return client.get.uri/claims, retrieve body to mono. This is a map. and block. And we're off and running there. We'll do a get mapping / email, and we'll return a string get subject and return client.get.URI. In this case, it's email. Retrieve body to mono. This is a string once again, and dot block and format. There we go. Okay, now let's restart and see what we have. We see that we're running here with our resource server, and our application, our initial application, is up and running. So let's go back here. Oops. Okay. Well, let's reopen that. Localhost. Oops. Localhost 8080. So we're going to log in with Okta Mark. Oh yes. Well, it helps when you select it. And we'll log in. And yes, that's great. But now we need to try to access something on the resource server. So we simply point to something. This is truly, really something. And now we will go to our claims. Look at that. Everything is working as expected. So we see our claims, which include our scopes, our subject, our version, our issuer URI, expiration, so on and so forth. So we've got everything there that we think we need. Let's go ahead and just make sure we can get to our email, our subject, if you will, and boom. So everything works. Crazy, right? Okay, well with that, we're pretty much exhausted on time. So I'm going to go back here and finish up and share the additional resources. So everything you saw here, code-wise, is available at my repo under my GitHub account, mkheck, at Spring Security OIDC OAuth2. If you want to know more about protocol patterns, the different authorization flows, then you should check out Joe Grange's OAuth2 protocol patterns repo. Joe Grange is our Spring Security OAuth2 ninja. He leads our OAuth2 efforts within the team. Other great contributors as well, but Joe has this really nice repo put together with the different flows, which are super useful. And then, of course, the Spring Security documentation page. It's also the jumping off point to get to the repo for Spring Security, the repos, I should say, with the various different projects. With that, I have to say goodbye. Thank you so much for coming. Please stay in touch, stay secure, and stay safe.